So hello everyone, today I am going to explain a very important chapter of class 10th science, and the name of the chapter is magnetic effects of electric current. So as we have got in the previous classes that electricity, it has three major effects, and those are heating effects, magnetic effects that we will learn today, and the chemical effect. So the name of the chapter is magnetic effects of electric current. Now, when we talk about the magnets, then there are generally two types of magnets. One is natural magnet and another one is artificial magnet. The natural magnets are like lodestone and artificial magnets are of two types. One is permanent magnet and one is electromagnet. Permanent magnet, for example, are bar magnet or horseshoe magnet that we use in our daily life. And electromagnets are those magnets which are artificially produced when electric current is passed through a conductor. Now, when we think of a magnet, then generally a scenario of bar magnet comes to our mind. And a bar magnet has a magnetic effect around its field, and that field is produced by the magnetic field lines, and all these lines are the magnetic field lines. Now, it has some properties, like if it is the magnet it is north pole and it is the south pole, then the direction of the magnetic field will be from north to south, and inside the magnet it will be from south to north. Also, the magnetic field lines, as you can see here, they don't intersect each other, because if they intersect each other at a particular point, then it will mean that at that particular point there are two directions. So it is literally impossible to have two particular directions at the same point. Therefore, they don't intersect each other. And the next thing is that all these magnetic field lines are close curved. Near the poles, they are crowded, and apart from the poles, they are far apart. And the place where those are crowded, it has strong magnetic field. And where they are apart, they have very weak magnetic field. The magnetic field lines, they have both magnitude as well as the direction. So since they have both magnitude as well as direction, therefore it is a vector quantity. In the previous classes, we have got that in a magnet, the like poles repel and unlike poles attract. Suppose it is one magnet and it is the another magnet, and if the thumb finger is representing the north pole and if it is also representing the north pole, then they would repel each other. But if the thumb finger is representing the north pole and it is representing the south pole, then they would attract each other because they are the unlike poles. Now the fact behind is that it is the figure to explain about the fact. Here it is denoting repulsion and here it is denoting attraction. As we got that a magnetic field is created due to the imaginary magnetic field lines around the magnet. Here we can see that it is one magnet and it is a magnet. It is the north pole and it is the north pole. So the direction will be north towards south, and here north towards south. These all magnetic field lines are moving north to south and north to south. But here they are in north and north. So the field lines would try to move from north to south and north to south, and because of that they would repel each other. But here the direction is from north to south in this magnet, and here also it is from north to south, but here the magnetic field lines has found a short distance, that is from this north pole of the magnet to this part, that is south pole of the another magnet. Therefore the magnetic field lines would move to this side, from this north to this south, and they would attract each other. So that is the main logic behind it. Why does two poles of a magnet attract and repel each other? The next topic is that Maxwell's right-hand thumb rule. And before going to understand this concept, we have to understand one diagram. This diagram, here it is a circuit, closed circuit, and it has two cells forming a battery. It is the positive terminal and it is the negative terminal. Here it is an ammeter, it is a rheostat or variable resistance we can say, and the direction of the current when switch on is from positive to negative, and it is a part of the circuit XY. Now, when current flows from X to Y in this cardboard, a magnetic field is produced around the conductor. It is a straight current carrying conductor and concentric circles are formed in it. And the concentric circles which denotes the magnetic field, its direction is towards the direction of a clock, that is clockwise direction. When direction is from X to Y, that is downward, then direction of the magnetic field lines would be from means it is in clockwise direction. But if I change it, that if it suppose becomes negative and it becomes positive, then direction of the current will be from Y to X, then the concentric circles, its direction would be changed, that it would become anti-clockwise. And from here we get a rule known as Maxwell's right hand thumb rule. That means a scientist named Maxwell, he proposed this rule. When the direction of the current is in upward direction, then the magnetic field lines, its direction would be anti-clockwise, and when the direction of the current would be towards downward, then the magnetic field lines, its direction would be clockwise. So by applying Maxwell's right hand thumb rule, we can understand this diagram. Here it is a circuit where it is a circular loop. When the current flows, that means from positive terminal to the negative terminal, then at each and every point magnetic field is produced. As we know that when electricity flows in a current carrying conductor, then magnetic field is produced. In the same way, here suppose these are 2 points, and at both the points magnetic field is produced. Now the direction is from positive to negative, that means here it is in upward direction. So by applying right hand thumb rule, we can get the direction of the magnetic field. It is in upward direction, and my fingers, it is in this order. That means when the current is in upward direction, the magnetic field direction will be anti-clockwise. Here the concentric circles, its direction is anti-clockwise. But after moving through this way, the current, its direction is downward. So by right hand thumb rule, it is in downward direction, so the magnetic field direction would be clockwise. And a very easy way to remember it is that clock face rule. If it is the north direction and if it is the south direction, then N means north, so it is in this direction. That means it is denoting anti-clockwise direction. And if it is the south pole, then it is clockwise direction. So if we see from this part, then it would be clockwise, and if we see from the another side, that is the north, then it would become in anti-clockwise direction, the magnetic field. So the next important topic is solenoid. And the solenoid, we can define it as like a solenoid. It is a coil which has many circular terms of insulated copper wire wrapped closely in the form of a cylinder. Like here we can see the diagram. It is a solenoid. These are the magnetic field produced due to the electric effect. It is the south pole and it is the north pole. Here it is the battery whose it is positive terminal and this is the negative terminal. When it is switched on, the current flows from positive direction and through this coil to the negative direction. And because of the electric current, a magnetic field is produced whose direction is, as we have got earlier, it is from north to south outside the magnet, and inside the magnet it is south to north. And inside this solenoid, that means the artificial magnet, the magnetic fields are uniform. That means they are parallel to each other, and here they never intersect each other, as we know. Now the appliance of solenoid are used in like electromagnets. These magnets are made when electric current it flows through a current carrying conductor. There are some tips to increase the power of a solenoid. Like it is the coil. If we increase the number of coils, that means n number of coils if we use or more, then the magnetic power can be increased. Also, if we increase the electric power, then also the magnetic power would increase. And also by changing the type of material, that it depends on the material also. Next, we can differentiate between permanent magnet and electromagnet. Like permanent magnet, its magnetic power is fixed, means it has a fixed magnitude. But electromagnet, its magnitude is not always the same, because whenever the current fluctuates, its magnetic flux also increase or decrease. Like if we increase the current, the magnetic flux would increase, and if we decrease the amount of current, then the magnetic flux would decrease. Also, a permanent magnet, it cannot be demagnetized, but a electromagnet can be demagnetized. Next, the polarity of the permanent magnet is same. Like if this part is the north pole and it is the south pole, then it will be always the north and the south. But by changing the direction of the current in an electromagnet, the polarity can be changed. That means the north pole can be made south pole and the south pole can be changed to the north pole. So it is all about a solenoid. So the next topic is Fleming's left hand rule. The scientist named Fleming, he introduced this rule. By this rule, we can find the force direction when we know the direction of magnetic field and direction of current. And while using this rule, we use our left hand. These fingers, thumb finger and both these fingers, all are perpendicular to each other. That means at 90 degrees. This finger, here the thumb finger, it represents the direction of force. This finger, it represents the direction of magnetic field, or B, and the middle finger, it denotes the direction of current, that is I. Now, by using this rule, for direction of force, it is about the direction of the magnetic field, and it is about the direction of current. If we know the direction of the current and if we know the direction of the magnetic field, then we can find the direction of the force, that it would be towards upwards. Like here, if the direction of the magnetic field is upward and in this way, then the force would be in this part. So it is about the Fleming's left hand rule. We are ready to understand the working of an electric motor. Electric motor, it is a device that converts electrical energy into mechanical energy. It is a schematic diagram of an electric motor. Here, these are two magnets. It is the north pole, it is the south pole. It is the whole circuit of the motor, and these are combination of two cells in a series forming a battery, where this is the positive terminal, it is the negative terminal, and it is the switch, and the direction of the current is from positive in this way to the negative. Here we can see that the direction of the current is in this manner, and the direction of the magnetic field is from north to south. This X and Y, it is called as commutator. A commutator, it is a device which is used to change the direction of current simultaneously. And in an electric motor, the commutator is called as split rings. These split rings, after half revolution, it simultaneously changes the direction of the current. Here, these are the two brushes. It is generally made up of carbon, and these brushes connects the circuit of the motor to this external circuit connecting to the battery. Now, by using Fleming's left hand rule, we can understand the working of this motor. The direction of the current is in this way, and the direction of the magnetic field is from north to south. So, by applying Fleming's left hand rule, we can see that it is the direction of the magnetic field, that is north to south. It is the direction of the current, that is in this way here. So the direction of the force will be towards downwards, that is when BA moves downward, then CD will simultaneously go upward, and also this part would change its position. Now when it goes up and down, then this gap would come here, and therefore the current would not flow. But since this part would have the momentum, therefore again it would move and the circuit would be again switched on. So this process would continue, and the motor would rotate until and unless we switch off the circuit. So it is the working of the motor. Now there are many commercial uses of motors, like in our home, in electric motor for pumping the water and all we use motor. The commercial motors, it use generally three things, that is, instead of a permanent magnet it uses an electromagnet. There are many turns in the coil so that the power of the motor increases. Also the soft iron core is used in which the coil is wounded so that the motor works more efficiently. We also need to understand about the principle of an electric motor. It is very simple, that when a coil is placed perpendicularly to the magnetic field and electric current is passed through it, then a force works on it, due to which it starts to rotate, and it happens in the electric motor, due to which the coil rotates and we get a motor in its working condition. So the next topic is electromagnetic induction, and it is also an important and very interesting topic. Here it is a diagram to show electromagnetic induction, where these are two coil number 1 and coil number 2. This is the battery and it is the switch. When the switch is on, then the current flows through this direction, and after the flowing of the current, a magnetic field is produced. Due to the production of the magnetic field around coil 2 changes, and when the magnetic field around coil 2 changes, then it induces a current, and the current can be detected by this meter, which is called as galvanometer. Actually, galvanometer, it is a device which is used to detect the presence of current, and as well as it can denote the direction of the current. Now here, when the magnetic field is changed, then the current is produced, and since the current is produced, the galvanometer can detect the presence of the current. Electromagnetic induction, we can define it as like when the magnetic field around a coil is changed, then a coil near to it, the current is induced, and it is the diagram of electromagnetic induction. Actually, it was accidentally discovered by Michael Faraday in the year 1831. Fleming's right-hand rule. So Fleming's right-hand rule, it states that we can find the direction of induced current if we know the motion of the conductor, as well as if we know the direction of the magnetic field. Here in the right hand, if we place all this finger at perpendicular, then this thumb finger will represent the motion of the coil. This finger would represent the direction of the magnetic field, and it would represent the direction of the induced current. That means if the direction of the motion of the coil is upward direction, and if direction of the magnetic field is in this direction, then the current that means that is induced would be in this direction. So it is about the Fleming's right hand rule, and its appliances is in like electric generators and all. So in class 10th term 2 syllabus, electric generator is not included, so we will not be discussing about it. It is all about this chapter, that is magnetic effect of electric current, according to the latest term 2 syllabus of class 10th. I hope you like this video and you have understood all the topics. See you in the next video. Jai Hind.